Hello, my name is Michael Sliwa, and today we are going to be looking at the following problem, which is to draw the mechanism with structures, then write out in words to describe the mechanism for the following reaction, which is pent 1 ine reacts with sulfuric acid and water. So we're going to first start by drawing our reactants here. So for the name here, we have pent, which is 5, 1 ine. We're going to have an alkyne, which is a triple bond, and it's also going to be at the end of our carbon chain. So we draw 1, 2, 3, 4, 5 technically. We have 4 lines but 5 carbons here, and then we're going to go ahead and put the ine, the 1 ine, over here, and that gives us our starting structure, which is then going to be reacted with sulfuric acid, which is H2SO4, and also water, which is obviously H2O. Now what's going to happen here is this proton here on the H2SO4 is going to go ahead and provide a positive charge, which one of these pi bonds here on the triple bond are going to want to be kind of reacting with here. So that's going to go to that positive charge, and it's going to kind of work like a lone pair of electrons, and that's going to form a new bond, thus pushing it off of the HSO4 minus anion here. And that's going to form the second step here, is going to be the same exact thing, except we're going to have a double bond here, and we have to look at where our hydrogen is going to be bonding, because it can either bond here or here. In this mechanism in particular, we're going to be looking at the Markovnikov product, which will have the carbocation in the most substituted position, which would be here, and that would place the hydrogen over on this end. And we're going to end up not showing this in the future, but showing it in this step is pretty smart because it kind of shows us where this new bond is going to be forming that we did in our first step. Then what's going to happen is that our water is going to come in with its lone pair of electrons on the oxygen, and that's going to attack this positive carbocation, thus forming the following product here. And right here, we're going to have the entire water come in and bond with a positive charge here, due to the fact that water here is going to have 2 electrons coming from these bonds with the hydrogens, but only be having 1 electron here from this bond with the carbon here, so it'll have 5 electrons when it wants to have 6, and therefore have that positive charge. So following that, water will come in again, and it's going to go ahead and remove one of the protons from the end of the water bonded here, so that's going to push this hydrogen off and push the electron pair onto oxygen, therefore in the next step here creating this product, which is going to have an alcohol looking structure here, but this is actually an enol, because we have this double bond here to the hydroxide group. And lastly, we're actually going to undergo a process called tautomerization, where this double bond is going to come in here, push onto this hydrogen here. The bond between these two is going to go ahead and bring its electrons here and form a new double bond, therefore creating the following product. Will look like this, and this is a ketone, which we could go ahead and name. So we have a ketone at the 2 carbon, so this will be pentan. We haven't changed the number of carbons we have to one. And that basically wraps up our mechanism, showing where everything is going, including the electrons and things of that nature, new bonds being formed, and how tautomerization ends up occurring at this step here. So now we could go ahead and just formally write this out in a way that, would be in words, even though we just kind of went over it in words as well. But I think it's good to do that, to go ahead and review, and it is part of the problem. So first, we're going to write what's reacting here. So pent 1 ine is allowed to react with sulfuric acid in water. In the first step, a pi bond from the pent 1 ine triple bond will act like a pair of electrons. I guess lone pair would be better. Lone pair of electrons bonding with the positively charged proton on sulfuric acid. This will form a carbocation intermediate with an alkene being formed as the triple bond would be changed to a double bond. The carbocation will form on the 2 carbon with a new bond to hydrogen, forming on the less substituted side of the double bond. So that puts us about here, and then we could say then in the second step, a lone pair of electrons on the water oxygen will attack the positive carbocation site forming a new bond between the 2 carbon and the entire water molecule at oxygen. In the third step, water will come in again, acting. I'm going to go ahead and kind of make a little squiggly there, and we're going to go ahead and move up here to continue writing this description. Acting as a base to deprotonate one of the water hydrogens, pushing the electrons from the broken bond between oxygen and hydrogen onto the positively charged oxygen bonded to the 2 carbon. So that's what's going on here. And then what we could say from here is that, basically, that this would form, so this forms an enol with OH and a double bond on the end of the 5-carbon chain. And now we've completely ran out of room, so I think I'm going to go ahead and clear a part of the screen that we can continue writing this out in. I've been kind of saying it verbally as I write it, so hopefully that helps a little bit, but the entire solution should all be here following that. So now we could say in the final step, tautomerization will occur with the pi bond in the double bond coming in to remove the hydrogen bonded to oxygen in the hydroxide, while also pushing the electrons from the OH bond onto the bond between oxygen and the 2-carbon, forming a new double bond between oxygen and the 2-carbon. So that's all that was going on in this step here with the tautomerization. And basically we could go ahead and wrap up this description of the mechanism by writing the name of the product. So we could say this forms the product pentan 2-one. That's our whole entire mechanism description in words. I know that I kind of went crazy as far as writing it out, but hopefully with me saying it along with me writing it, everything can kind of be shown here. As I was writing it, I also noticed that I forgot to mention the formation of this positive charge, but I kind of talked about that as I was going through the actual description of the problem when I was writing out the mechanism, so hopefully that's pretty apparent that, you know, that's an important step here that should be included in our mechanism written description. But yeah, we pretty much did everything we need to do for this problem. We wrote out the mechanism and then used words to describe what was going on in it. So hopefully it was pretty easy to follow, and that is the entire problem, like I said.